Everybody having a good time? All right. Well, if the people in this room are representative of the people who filled out the questionnaire for the conference, most of you, I hope, are relatively new to the Android platform. So I wrote this presentation with an eye in that direction. So it's very high brush strokes of what the platform provides and the features and how it all fits together. And if you need more details, well, sorry, this is the wrong presentation. You can ask during the QA session. Darn, I forgot the QA slide. Anyway, what's in Xamarin.Android? We have IDE support for Visual Studio and for Xamarin Studio. We have Runtime. We have glue, more glue, baling wire, and duct tape. Sorry, that's the Java library binding support. We have packaging, more glue, and we have unified components, which bring all of these individual pieces and puts a nice little bow on top, so your development lives are a little bit saner. So that's always good. Visual Studio has a wonderful layout editor, GUI, WYSIWYG, the whole bit, except it's not as nice as the just announced iOS editor that lets you drag images and views from your referenced libraries. That's a nice feature. We don't have that. I would like to start working on that, though. That's a nice feature. We also have non-modal deployment. That is when you're busy deploying your app to the target, whether that be hardware or the emulator, we're not going to completely block up your entire IDE, well, on Visual Studio. And the seldom seen target selection dialog box. If you go into View, Toolbars, Xamarin.Android, all the way down at the bottom of the Toolbars menu, there's this little drop-down box. So if you have multiple targets attached to your computer, instead of having the dialog box pop up and say, which device do you want to deploy to this time, you can say, I want that one. And it's nice, saves time. Xamarin Studio is largely in the same boat. It also has a layout editor. Something that it has that Visual Studio doesn't have, which may have been covered in the previous iOS talk, is there is Razor HTML support. This isn't particular to Xamarin.Android. This is actually a Xamarin Studio feature. But you can do file, new file, general for pre-processed Razor template, and then you have access to a Razor file, and it generates a whole bunch of C# code that you can then integrate into your app. So if you're embedding a web view and you want a nice templating engine for all the HTML you're going to shove into the web view, this might be appealing, possibly. Then we get to the new foundation of the runtime. So forever, years and years, our products were based on the Mono 210 profile. Mono 210 itself in terms of the JIT, the GC, the class library support. And for our new beta that we announced today, we are rebasing a top 3.0, which fixes a number of bugs in the GC. It fixes a number of bugs in the class library. If any of you have dealt with the socket type before, we used to have methods that would throw not implemented exception, and now many of those are actually implemented. So that should increase compatibility for many of you. The other big change is a rethinking of how we structure the class libraries. In the previous release, in the current stable release, the class libraries were based on Silverlight with extensions, and that's Silverlight circa 2009 with extensions and removals. But the idea was Silverlight, primarily so that we would get a smaller API footprint so that we would not be dragging as much baggage onto the device because we were worried about application size. What we have done with the beta release is we've inverted that. So instead of starting with a small base and adding stuff to it, we're starting with most of .NET 4.5 and removing stuff. The biggest thing that we're removing is the system.configuration assembly because who needs it? And because there's a lot of XML stuff that it tends to pull in that you would normally like to remove if possible. So it's just a change in worldview. Well, one of the other interesting things that rebasing on Mono 3.0 is that it also gives us new base class assemblies and types. For example, we've got the new async-ready system.net.http assembly, and we've got wonderful async-ready methods like stream.readAsync. But the other thing it also does is it upgrades the C# compiler and fixes many of our C# compiler bugs. So for example, previously, Java-lang object only has a protected default constructor. That code never should have been legal unless outside of Java-lang object or when you were subclassing it. But if you had your own utility code, you should never have been able to do that. But you could because of a compiler bug. If you were on Visual Studio, you never hit that bug because you had a working compiler. With the new 3.0 base, we are using an updated, improved, bug-reduced compiler, and so this properly generates a compiler error. But if you accidentally did that, and I have on more than one occasion, you may run into that. Something that we've had for a while, in partially supported form, is C#4 Dynamic. Now, if you've never seen C#4 Dynamic, it is awesome sauce with a cannon pointed at your leg. I mean, it's awesome. Yes, it's truly awesome. So this is a C#4 Dynamic example that an acquaintance of mine in Richmond, Virginia wrote, Kevin Hazard. And so what we have here is we have this blob of XML code. And of course, you could parse and interpret it based on, Xlink or something sane like that. But sometimes you want things to be easy. So if you squint just right, dx is a dynamic object type, but we've declared it as dynamic, so that means that all the type and member lookup is done effectively at runtime. And so because of the way that type is implemented, and you can go to the URL to see how it's implemented, but because of it, you can use the XML element names as properties on your C# expressions. So because we have a book element, we have a book field, in effect. And because we have a pub date attribute, we have a pub date field in the expression. And so we can just merely walk along using expressions instead of doing XPath or some other arcane Xlink syntax in order to extract this data. And it looks phenomenally cool until you try to build a release build and run it on your device. And then it blows up. But hey, if it's a debug build, it works quite nicely. But still, awesome sauce. A new feature is we are finally getting support for C#4 variant generics, that is covariant types and contravariant types. These are also awesome sauce. So we've got the new declaration for IEnumerable and IEnumerator, and those are declared as out. They are contravariant, I think. I always get the two confused. But what that means is that for a given t, and for example, look at cat, which is based on the Unix command line of the same name, we're taking an IEnumerable of stream. And so because it's out, any subclass of stream can be used instead of the type parameter. So you can do a new list of memory stream and pass it to our IEnumerable of stream, or we can do a new list of file stream or network stream or any stream subclass. And in C#3, that would have caused a compilation error. It would not work, so you'd have to use some workaround. Instead of having a useful data structure like a list of file streams or what have you, you would have to use exactly list of stream. Or you'd have to use some link query to manipulate the type into something that the function would accept. This makes it easier to use and implicitly converts the types, and quite handy. It's a feature I was seeing requested for in C# generics for ages and ages on the C# IRC channel. We are also have the task parallel library, and we have had the task parallel library for years, but the task parallel library is not necessarily easy to use, and so this is our setup for the next slide. So in this case, imagine you have, well, step back. As mobile developers, as we mentioned this morning, you want your apps to be responsive. You can't freeze the user interface for 5 seconds and expect anybody to be happy. So the way we make our apps responsive is instead of having blocking method calls everywhere, we make everything asynchronous through lots of delegate passing everywhere. So we've got get user async is going to be returning a task, and then we continue the task with another method invocation, and then we continue it with, oh wait, we have to manually check to see if an error was generated, and if there is, we can show it. Otherwise, we can update the GUI. The first post status async is going to be executed on a worker thread, on a thread pool thread. The second block is going to be executed on the user interface thread. It works, but it gets unwieldy fast, particularly if you start needing to nest these any level deep, or if you start coming from a Node.js background and see JavaScript nesting all the way down. Its closure is all the way down. It's like turtles. With the beta, we now have proper C# 5 async, which simplifies the previous slide immensely. Instead of needing to have to explicitly check some failure status and do something appropriately, we have nice, proper exception handling. The await calls are a way to say, you know that get user async, get back to me when it's done. So in effect, this method will implicitly return, and it'll come back when the data is available. And that allows the user interface thread to be responsive to the user's needs and desires and continue doing stuff, and allows you to keep your sanity and not pull your hair out while writing responsive, async-friendly code. So this is definitely the future. Then we get to other new features in the runtime. The new feature for the 4.4 series was that we changed the default ABI provided in app packages to ARM EABI v7a, and I'm going to call that ARM v7 from now on before I trip over my tongue. The problem here is, prior to this change, our default ABI was ARM v5. ARM v5 has the nice feature that pretty much every Android device ever shipped will run an ARM v5 binary, except those silly Google TV devices, but who cares about them? The problem with ARM v5 is that it lacks the assembly instructions necessary in order to have SMP-safe code. So as soon as you introduce a second core or a second processor, you're hosed, because there is no way to make that code run safely on a single core. And believe me, I have tried to make our code run on a single core and tie it there to avoid, there's a second thread, ignore it, don't use the second processor, I don't want the second processor. My workarounds didn't work. So we changed the default for the sanity of everyone, because if you've looked at least in this country, even the free phones that you get on contract from Verizon and AT&T and everyone else, those are all SMP devices now. Those are all ARM v7 devices now. If you're shipping something that only has ARM v5 support, you are going to get strange, bizarre, impossible to happen errors, and you're going to wonder why. This is why, because you're using the wrong default ABI. Now, you can embed multiple ABIs into your app package. It's in the project options page. But we wanted to stick to just one default, because each time you add an ABI, it makes the APK size bigger. So we wanted just one default, and we changed the default, and lots of people were sad because things no longer worked the way they expected it to, especially when combined with random Android package extraction and installation errors. And you can go read the CPU architecture documentation and then gasp in horror at the things Android has done to us. Well, I gasp in horror. We are also introducing F# support. This does not include the compilers. You can bring your own compiler. Actually, you can install Mono 3.0.10 on the Mac. That includes the F# compiler. I don't actually know where the F# compiler comes from on Windows, but I'm assured that you can get it from somewhere, right? But we are providing the F#.core assembly and probably a couple others so that the F# code that you compile into IL can be properly packaged and will execute as expected on the device. Good times. Binding improvements. Binding is the glue that brings half of everything together. It's what allows you to invoke Java code. It's what allows Java code to call your C# code. And way back in the day, what we decided, accidentally as it turned out, well, it wasn't a good idea anyway. What we decided to do was we decided to try to remove duplication in the API. So we've got system.xml. Why do we need java.xml? Ours is much better, right? We've got system.json. They've got org.json. Ours is much better, right? It's more compatible. We don't need to expose those other types. Well, as it happens, we do need to expose those types because every time you ran across a Java library that used one of those types, it would cause pain and suffering for you and us as we tried to diagnose the issues. So we're taking a, darn, I forgot the phrase. Mea culpa. And we are re-adding many of the assemblies, many of the packages that we had previously removed. So org.json is back in there. Java.xml is back in there. We only added 3 meg in size to Mono.Android.dll. That's why we have a linker. But this should help simplify using, binding new Java libraries. And of course, we always want to make things easier. We also have support for embedding Java libraries into assemblies. This is handy so that your binding assembly can be nice and useful in a standalone fashion. So instead of in your documentation saying, use this assembly, oh, and add this helper jar file to your application project and set its build action to Android Java library and whatever else you need to do. You can instead set the build action in the binding project to embedded jar. And so the jar file will then be embedded as a embedded resource into the assembly. And at package build time, we'll extract the resource. We'll extract the jar file. We'll use it for compilation purposes. It will wind up in the app package. So when you're doing unified components and similar things, as we'll discuss later, you just need to hand them your assembly, just the .dll, and that should be most of what you need to do. The packaging process will handle everything else. There is also support for Java library projects. So if you're using Eclipse, or you're using Ant, or you're using the Android SDK build system, which occasionally uses parts of Ant, you may have a project.properties file. So what you can do is you can reference that project.properties file from a binding project and set the build action to library project properties, and we will try to read that project.properties file to find the jar files that it built. So if you have an existing Java code base, this can make things easier to bind the stuff that was built elsewhere. Java library projects can also contain Android resources, but they do it slightly differently in that they require that you refer to the entire directory structure in order to do things from Eclipse. Well, we don't want to be referencing entire directory structures. That gets cumbersome. So what you can instead do is you can take your bin directory from the Java library project build, so your jar file and all the asset resources and everything else. You can zip that up into a single file, and then you can add the zip file to your binding project and set the build action to library project zip. And then we will traverse that and add all of those as resources that can be used by referencing applications. What's new in app packaging? App packaging is the process of creating the .apk file, the application package. This is where a lot of duct tape comes together to glue the two worlds. We are introducing support for native library remapping. So if you have a regular pinvoke, a regular DLL import, and you need to reference a shared library name, very often the code that you are using will be using the Windows library name, which may or may not be appropriate. And for a while, Mono has had a way to provide a .dll.config file, which is used to rename which native library we actually look up, so that you can use, say, libgtk Windows in your DLL import so that it runs nicely on .NET, but you can provide a config file and it'll look for GTK Unix or something when running on a different platform. So we are now providing support for that. We will be providing support to, quote, bundle assemblies into native code. If you are familiar with the make bundle program from Mono, that will make perfect sense to you. If you're not familiar with the make bundle program, what it does is it takes all of your assemblies and it adds them to a native library, a .so file, as a blob of memory. And so instead of having the assemblies in the APK stored uncompressed, what you instead do is they are all stored as a single file, a native file that is compressed. And so this will allow us to make things slightly harder in terms of copy protection measures to gain access to the IL, because then you'll need to dig into some native library to extract the resources, and that might put some people off. It's not bulletproof, although arguably nothing is bulletproof, but it is yet another security mechanism. We also have environment support. So this allows you to take a file, a text file, and add it to your project and set its build action to Android environment. And the contents of the file are primarily key equal value pairs or comments. You can have a line starting with the octothorpe, and it'll be a comment. But if the key starts with a capital letter, it'll become an environment variable. And then you can access it in your code from environment.getEnvironment variable, and it all just works. Or if it starts with a lowercase value, it'll set system properties, Android system properties that can be overridden, or in particular that Xamarin.Android will look for at startup. So for example, suppose you have a customer who is causing your app to crash for one reason or another. And for the sake of argument, you decide that you need to get gref logging enabled on their device in order to help figure out the crash. Well, previously, the only way to get gref logging enabled was to hook up your device to ADB and do ADB shell set prop debug.mono.log gref. And nobody but a developer is going to figure out that entire process. So what you can instead do is you can add that line, debug.mono.log equal gref, to the environment. And so at startup, we'll read that, and then we'll set it as if the user had done ADB shell set prop debug.mono.log gref. And so that means you can just hand off an APK to someone else. They can run it. It'll spam their logcat. You can get the device back and then copy off the logcat, and it makes things slightly easier. Or you could, in retrospect, I'm not sure I was setting debug.mono.env, since you could instead just set the environment variable. But. Yes, it's just spread out all over the doc site. I can show you where in a bit. All right, library resources. How am I doing on time? I'm not doing too bad on time. Wow, impressive. All right, in the 4.4 release, we added the ability for library projects to contain Android resources, which means that you can have a library project which has a self-contained activity. It would have layout XML, it could have images, it could have strings, it could have everything that you want. And it's in a nice, small, self-contained assembly, and you don't need the app project to do anything to use that assembly, which was frequently requested by component vendors and the components team. So that's nice, even if we do occasionally keep breaking it. But it's something we want to keep working on. We will be adding the ability to embed native libraries, .so files, into the library project assemblies as well, and they will get extracted into the app package and installed along with everything else. Now, one problem with a workaround is that our default library template frequently does not have support for Android resources. Although I have run across one case where it did have support, so I'm not sure where it works and where it doesn't. But if you happen to be in the environment in which the default library template doesn't have the resources directory and you can't figure out how to add Android resources, what you can instead do is you can create a new Android application project and then just edit the csproj file. It's an XML file. It's ugly, but it's an XML file. And just remove the Android application element. Save, reload the project. You now have an Android library project that has Android resources in it, plus the pre-created directory structure with all the sample layout XML and the sample strings and the sample everything else. So it helps get your project set up. We also have support for the export and the export field custom attributes. This is useful for Java interop. One bug report / question that came on the mailing list many, many moons ago was pretty much this scenario exactly. It was going, I've got this button in my layout XML, and I'm using the Android onClick property so that I can have my method invoked when the button gets clicked, instead of using the click event or an onClick listener or any manner of other things. And it blows up at runtime because this method can't be found. How do I fix it? Well, we finally, well, as of 4.2, we do have an answer for it now. We have the export custom attribute. So if you place that on a method, that method will be exposed to the Java world. The Android callable wrapper that we generate in order to hook things up with Java land will have this method present, which means Java Reflection will be able to find it, which means you can now use the onClick attribute in your button. That does not mean you should use it, but you can use it, and things will work. The export custom attribute is also required if you want to implement the iParcelable interface and the Java iSerializable interface. And it can also come in handy if you have Java code that is attempting to consume your code. You can add specific methods to facilitate the integration. We also have AIDL support. AIDL, the Android Interface Description Language, is basically an RPC mechanism. And if you've used any form of RPC, like COM, DCOM, Corba, XPCOM, and Mozilla Land, they all have some flavor of IDL to describe the interface and the messages that can be sent between the messages. So, of course, Android has its own flavor of IDL. It's slightly more Java-esque than OMG IDL, but similar enough. And so we have a package where this particular interface, the iMarket billing service, lives. We can import Java types that this particular interface makes use of. And so if you have a file with these contents and you add it to the project and you set the build action to Android interface description, it will generate a mess of C# code, which is fair because when you do the same thing in Java, it just generates a mess of Java code that does the exact same thing. So we're following suit. And so you get the C# interface that you can implement in your code. It generates a service stub, which is used by service code so that you can bind to a service and invoke remote methods upon that service. And it generally just works. You do have to squint a bit at times, though, because the AIDL has to reference the Java type names, whereas the generated C# code will, as always, have our wonderful Pascal-cased type names. So there's a slight inconsistency there, but sorry. Which brings us to unified components. So a component assembly, as you can find on the component store or as you can build yourself, is an assembly that can contain your normal CIL, your common intermediate language. It can contain your standard embedded resources. It can contain Android resources. It will be able to contain native libraries. And it will be a generally self-contained unit. So you can just send somebody a copy of the DLL, and they can just add it to their project as a reference, and things will work miraculously. Because that's how much I like glue. I like miraculous glue logic. And one of the other things that we just fixed in the 4.6.3 release is we now support satellite assemblies, which are useful for regex translations if you happen to use regex as a translation source. So now you can get easier localization logic into your app if you wish to stick with .NET regex files instead of using Android resources. The one thing to keep in mind, though, is that layout XML files won't be able to reference your strings that are coming from embedded resources. So user interface strings probably should not use the embedded resource satellite support. They should continue to use the Android support. And that is actually the end of my presentation because I forgot to put in a QA slide. So any questions? Easy crowd. Really? Nothing? We have a microphone. We have a helper. Oh, good.
When we package Android applications, we see that Mono gets installed separately and Android package gets installed separately in the Android phones. Is that true?
Yes, for debug. Oh, sorry, let me repeat the question. She's noticing that when you install an app onto an Android device, the Mono package is installed separately from the application package. Yeah. And that is true for debug builds. That is, the Mono package is big. It's like 10 meg in size. And then there's the Android platform package, which is like 15 to 20 meg in size. So instead of needing to deploy those every time you want to deploy your app, we deploy them once-ish. So we deploy them once, and then we can reuse the Mono package and the Android package. And then we just need to worry about updating your app package, and it should be significantly smaller. And we found that a lot of the overhead in deploying apps to the device was just how big is the app. The bigger it is, the longer it takes. So by pulling out all those dependencies and installing them separately, you'll see that the first time you deploy to a device, it'll take forever. The second time you deploy, it'll be significantly faster because you just skipped 20 megs of downloading that you needed to do over the USB cable.
But is this only with the debug version?
Yes, it's only the debug version. The release build integrates the mono runtime into the APK so that it is standalone.
Okay, so the users into whose devices we give the release version, they cannot uninstall Mono separately. Only if they uninstall the Android app that we have given, Mono also gets uninstalled. Is that right?
I did not understand the question, I'm sorry.
Yeah, so since in the release version, Mono is packaged into the Android APK file itself, you cannot do an uninstall of Mono separately. Is that right? Because in the debug version I tried, I uninstalled Mono and my app refuses to work.
Right, so let me repeat that. If you have a release build of the app installed on the device, you cannot uninstall the mono runtime.
Yeah.
That is correct because the mono runtime is integrated with the app itself.
Okay.
So the next question or the follow-up was, you had a debug build and then you uninstalled the mono runtime and now your app doesn't work. And that is correct because your app is trying to look for the mono package installed on your device so it can find the JIT and the runtime, and it's not finding it. So it's bailing.
Okay, thanks.
I wasn't sure when you were going through the C# syntax stuff, but is there any difference in the C# language capabilities if you're on Android versus iOS? Is everything the same, async, await, all those things that you covered? Are there any differences?
Are there any differences in C# between iOS and Android? Syntactically, no. At runtime, yes, in terms of the types that you can reference. For example, you can use system link expressions, and we will fully support system link expressions on Android. iOS does not fully support system.link.expressions. Similarly, you can use all of system.reflection.emit on Android. You can't touch that at all with iOS. And so, which brings us to dynamic support in the C# language. You can use it, well, in debug builds, you can use it just fine on Android. Dynamic does not work very well yet on iOS. And even as support improves on iOS, I don't think it will be able to work fully.
In the iOS talk, Miguel mentioned Razor support. Is there Razor support on Android?
Razor support is a Xamarin Studio feature. So yes, you can do it.
We were here late. Is that what happened?
That's fine, that's fine. It's not supported in Visual Studio yet. I don't know why not. I don't know what it takes to put it in either. That's not my department, as they say. Did I repeat that question? I forgot. The question for reference was, iOS has Razor support. Does Android have Razor support? And yes, we do. But that's a Xamarin Studio feature. So that's an IDE feature, not an Android feature. It just generates C# code, and then we consume the C# code. And we don't care where it came from, we're just consuming it.
So all that work happens when you compile your app, not at runtime.
Correct. All that happens at compile time, not runtime. And then she's next.
What exactly is a Razor template?
Good question. Well, that's not full screen, is it? Whoop. That is a Razor template. Can you see it that well? I need to scroll it down so it's on the screen. But so you have an app model, and then you can have at helpers, and then you can have your normal HTML, and then you can have at keywords so that you can embed, well, you can insert C# expressions into the middle of your HTML. So it's just a templating engine. Are there any plans for a Razor Designer? That's not my department. I don't know.
So Xamarin.Android is using .NET 4.5 now, right? You said the latest version is 4 or 5?
Are we using .NET 4.5? There are
Yeah.
multiple ways I can interpret that statement. We have an implementation of the .NET 4.5 profile assemblies.
Okay.
And so we are using that as a basis, and then we are trimming some things out from that profile.
Yeah, and that's only for the Android portion. So typically most of the Mono projects, you have a common code base which is Android or iOS agnostic, and then you have Vue projects which are Android specific. So the Android agnostic, the platform agnostic pieces of code also will have .NET 4.5 support, or they are still on .NET 2.0 like earlier?
So will the platform agnostic pieces work on both iOS and Android? And the answer is yes. iOS is also getting upgraded in the same fashion. So if you are using the beta iOS product and the beta Android product, they are both providing the same 4.5 based API.
Yeah, but what we have noticed is Android and iOS supported 3.0 earlier, but the non-Android, non-iOS portions, the common portions, were using .NET 2 assembly still. The .NET Core was 2. So has that been upgraded to 4.5 as well?
The speaker has noticed that we are using the .NET 2.0 assemblies. I'll disagree slightly. They're not using the .NET 2.0 assemblies. They are using the desktop profile assemblies. So .NET 4.5 also has the same assemblies. So it's still MS Core Lib, it's still system, system.core, system.web, system.service model. When Microsoft introduced Silverlight, they moved some things around for inexplicable reasons, creating a schism between desktop assemblies and Silverlight assemblies, and we are continuing to use the desktop assembly names.
Oh, okay, okay, thanks.
So on the first day, I can't remember who mentioned that the Mono VM is faster than the Dalvik VM. So I was wondering if you could just give a little insight, like on a magnitude of, or for certain types of operations. You know what I mean? Like just kind of expand on that a little.
Not really. Dalvik Mono. I think this is it. And I think this has graphs at the bottom somewhere. So here we are. Let's zoom that in. That's the wrong way for zooming in. So if you're using generics, we're much better. Behold the power of proper generics. Oh man, and they don't have any other timelines. These are the only public numbers I know of. I did not personally investigate the timing difference between the two, so I can't speak in depth. But I do know that a lot of it is because the Dalvik VM is a hybrid interpreter JITting VM, whereas we are not. So the first few times you invoke a Java method in Dalvik, the entire execution is interpreted, which can slow things down, and there are trade-offs involved. But if you're looking for maximum performance, those interpreted calls are going to be a pain. But if it's in an inner loop, well, then you'll call it enough, and it'll eventually get JITted, and yeah.
When I was trying to make an Android library for a component in a component store, I was also trying to embed images as default images. And while I was able to compile it, when I used the library in an actual application, I was getting a bunch of errors that sometimes happened and sometimes didn't happen, where it couldn't find the image on loading. Is that what's being fixed with the hack you displayed on the slide?
Which hack on the slide?
There was something about Android.
Oh, that hack.
Yeah.
No, that's different. So what happened with what, I need to repeat the question. The individual had a component assembly they were trying to build, and the Android resources were not being embedded, or they weren't usable, or behavior was schizophrenic.
They were not really usable, although on compile time of the library they were included, but when I tried to use them in an application, it just couldn't find it on runtime.
Right. At runtime, were you getting an Android was there a resource .whatever in the app project?
Yes. And it allowed it once, and basically I could use it. It showed up in IntelliSense. I ran the thing, it worked. I ran it again, and then it suddenly couldn't find it anymore.
I will need to debug that because I have not seen that one before.
All right, okay.
I'm sorry. Is your hand up, or are you just holding it? Okay. Just checking. Well, I think that's everything, and we're only 12 minutes early. Not bad.